So the title here is Open Source Electric Vehicle.
Hello everyone, my name is Tim Gremman. I'm from Chalmers Robotics. It's a hackerspace in Gothenburg. I built this electric longboard and it's driven by a BLDC motor down here. BLDC, it stands for brushless motor running on DC. So the energy source is LiPo batteries. It's the same kind that is used in RC cars, RC airplanes. At the heart of this project is the motor control, the ESC. And it's developed by a guy named Benjamin Vedder. Maybe I should put this board away. So Benjamin has made this project all open source, and it's available at vedder.se. And here you could read some theory behind how a three-phase BLDC motor is controlled and how to use it. It's the processor on the ESC is an STM32. It's an RM-based processor, and he's made a nice interface to control it through and set some parameters and stuff for a motor controller, and it's written in Qt. And I should go through some basics of the electronics as well. So this is the basic electronics layout. So we got the microcontroller here, and we got a MOSFET driver. It's a driver from Texas Instruments, and then we're driving 3 FETs. It's like the transistors. So it's driving each of the phase of the motor, and it also got some features like it could communicate through UART. That's basically a serial, or you could communicate through CAN bus, or in other way you want to. I control mine through this V nunchuck controller. It's communicating through I2C, or I2C, I should be saying. So there's different methods, and if you don't like those methods, you could always implement your own, because it's open source. Thank you for me.
Thank you. So those were actually the 2 lightning talks that were signed up for today. But we have more time if anyone is interested in improvising or otherwise have something to say. You seem a bit interested.
Well, I can always talk about peer-to-peer if you're interested.
Yes, please do.
Are you? Yeah. Okay. I can do that improvise and leave it to you. Take a second to think. How long do you want me to talk?
Between 5 and 10 minutes. Is that okay?
Give me a few seconds to
Yep.
check my notes. What I can do that quickly. Okay. I think I can do without slides, but it's fairly simple. is I can tell what we can and can't do. I could talk a little about what we can and can't do with serverless peer-to-peer. I might be wrong now because it was quite a while since I did my research in this area, so I might have missed some new developments. Where I say that we can't do it, it's just I don't know that we can do it yet, so I hope someone else has solved it. But what I mean with serverless peer-to-peer is, in this case, on top of the internet, file sharing, for instance. But today we can do many other things. Let's see my notes. Unfortunately, I don't have my right paper for that now. We can do file sharing, of course. BitTorrent isn't completely serverless yet, but we can do also like Pirate Bay, but serverless. Totally serverless, including the comments on each torrent that is shared. We can do chat systems, and we can actually do the chat systems like RSC. We can do that better serverless than with servers. So in that case, serverless beats servers. For instance, serverless IRC server, which is you install your own little peer and you connect your IRC client to your local peer. That one would never crash, it would never get net splits, it would be always available as long as you're self-available. So not like IRC servers that go down sometimes and stuff like that. Instant messaging, we can do voice over IP, totally serverless. Many people think that Skype is serverless, but it isn't. It has 4 servers in Tallinn. But we can do that totally serverlessly. We can actually do internet gaming serverlessly, because internet gaming is pretty much the same thing as a chat system. When you enter, if you fly around in space with your spaceship, when you're in one sector of the game, everything you do, all the moves, if you broadcast that to everyone else in your sector, that's the same as broadcasting a message in a chat room. So from a protocol point, well, from a networking point of view, that's the same thing. And when you move into another sector, that's just another chat room. And also when you move into another sector, if there are like planets or, well, if another kind of world, you have to download how that world looks. But you can download that with, like in BitTorrent, kind of from other nodes and get all of that data. And it can be signed by the maker of the game, of course, so you get the correct data. So everything, pretty much everything you need in a server, in a real-time online game, you can do serverlessly, and with a big added bonus. Even when the manufacturer don't sell any more of this game or not interested anymore, as long as 2 players want to play it, 10 years later, it will work. Because they can play, so it never goes offline, really. Please ask questions if you want to. One thing is very simple to do. We can do radio and TV streaming to any amount of users. So you can put your own little TV talk show on Friday evenings, and you can have 1 billion listeners, and that's super easy to do. And you who know BitTorrent works, you probably already figured out how to do that. You just broadcast it. They send parts of the stream to some nodes, and they will then broadcast it further on, and they will switch packets with each other, and so everyone, after a few seconds, has the entire data. And you can do that continuously streaming forever. You don't have to just have, like in one BitTorrent, there's a BitTorrent swarm that is, file that is just a set amount of bytes. You just continue to do that. So you just have to modify the BitTorrent protocol a bit. What we can't do, one thing that we haven't solved really, we can't do Google serverlessly yet. There is some, they have tried to do that, and I think it was in Germany, but it's very hard because when you analyze, it becomes a very bad search engine, because on one web page you have very many words, and if you want to insert all those words in your distributed database that you would use in a serverless system, it becomes too many items to handle efficiently. So, and then also when you do searches, you have to correlate all of the words from different places in the table. That becomes too much traffic, so you would flood the network. So we can't do a really good search engine serverlessly yet, at least. I hope someone solves it. What more? Yeah, we can, as most of you already know, we can have anonymous networking. Tor network is actually kind of server-based. People put up donate server space where they run other nodes, but there is another network that is called I2P that is totally serverless, where if you are a client, you're also a node and helps out sending anonymous traffic. And that works since many, many years back. One thing we can't do on top of those, this gets a bit complicated. If you have a serverless network that is not anonymous, we can have services on top of it. Instead of servers, for instance, instead of someone having well, it's like a chat server, we can have it distributed. That's what I call a service. But if it's anonymous, we don't know how to have services on top of an anonymous serverless network. We can build them, but then it's really easy to crash them. So we don't have any robust way to do that. So that's not solved yet, as far as I know. So that was one of the targets of my research, and I failed to do that. So you can't do everything you want. Yeah. Well, we can do a serverless Twitter. That's fairly easy. So that was about it. Thank you. There was a lot of claims and no proof.
Thank you very much. Any other last-minute speakers here? Yes, Mehdi, come on up. So yes, please go ahead, 5 to 10 minutes.
Yeah. So it's more improvisation. I don't want to give you loads of information in 5 minutes, you know. But before I start, I want to ask you 2 questions. No, 3. How many of you know programming? How many of you know programming? Okay. How many knows or works in robotics? How many knows machine learning or did something about machine learning? Thank you. So, okay. I want to ask you some questions. I don't have anything to say. Okay, it's a question to think. It's not a question to maybe you know answers. Imagine that you're writing a code for a robot, and this robot has to think or act like a human. I want to give you simple example of human perception or action. How would you do that? So we had very good robotic person here, I would say. And we had peer-to-peer messaging talk now. I would say if I imagine myself as a robot, all of my sensor readings are message that's come to my brain and something happened there and I understand something. It's too simple, too simplified version of robot that I can imagine for myself, because it's not that easy. When I see a table, it's a board and some legs. Why is it table? Why is it, when I refer it to, when I want to send a message to another person, why would I call it a table? Why wouldn't I call it that sensors that I read? Why I don't send that message? Like how can I, how would you decide that that's table or just a board of leg thing? Why don't you choose that? Or when you see a book, you call it a book. You don't call it a piece of information. Oh, okay. Maybe I should go on and give you more examples. Is there any way to store information not symbolically? We need symbols to restore, or we perceive something, we generalize on it, and we only store them as symbols in our brain or in our memory. It seems human brain is, it seems our language is symbolic, but I don't know if we actually restore it symbolically. Yep.
About the memories and how we work, not computers. there are been research on people who learn speech at the adult age because they were deaf or something, and they get access to a language when they are adult. And when they talk about the time before and what happened then, they don't have memories of it. They can't relate to that time before. Which indicates that either it's because how we perceive our memory changes, or that it's really hard to make memories without symbolics.
Although a language that would be more a description than purely symbolic would also not be remembered. I think one additional thing is that when we do learn words or learn to classify objects as children, we do learn the symbolic forms long before we learn to describe it in a way that is unambiguous. So like you can learn the word table when you're 3 or 2 or even 1, but you don't learn to it's a horizontal rectangular plate resting on legs used until you're much older.
Yeah, I think when you get older, you can describe it with other words, but still you can see it with same sensors or similar sensors. I mean, okay, as a kid who learned table as a name, as a label for that sensor reading, and you can see that table from this direction and the other direction, and you can see it as a table. It seems that from even when you're very young, you in your brain you had this feeling that okay, you can imagine coming here and see that table from the other direction, and well, sensor reading is different from the other angle, but still you can understand that table.
A funny thing related to exactly this example from image recognition, perhaps you call it, is when you train a computer with neural networks to recognize a table, and just like kids can do sometimes, when you then remove the table and put lots of other stuff, it will say it's not that, but put a chair there and it calls it a table because it looks so similar. And kids do that too. They learn one thing and put something that's fairly similar, but whereas grown-ups think it's not the same thing, they think it's similar enough and say, yeah, it's the same thing. So it's a funny thing that the chair is a table for the computer at first, until you train it even more, that there's a difference between those two, because it's a flat surface with 4 legs too.
Our brains have many associations in our brains that we make, and when we see that what is named ryggstöd for the back, then we associate that with chair, and we could make that association. So our recognition of objects is made out of many associations.
Yeah, but I wanted to go to this direction to see how would you, as people who program, how would you program, how would you write a piece of program that receive a message and store it as symbols but not symbols? You can change those symbols.
What is symbols but not symbols?
But symbols like table as a symbolic representation, as label for series of sensor readings maybe, or possible future sensor readings, or a classifier for
You could store it by an analog photo, maybe. That isn't a symbol. That's just a form, a reflection of the.
Well, you should need some kind of abstraction, like in
yeah,
language.
abstraction.
I mean,
That's my
there is a part of the brain, reticulary activating system.
Okay,
That's actually
how would you write abstraction as a programmer? I think
Actually, in some there is 2 approaches that I'm aware of. Actually, we don't write it. We train a neural network, and then the settings for that network is the code. So then you just copy the settings to the next neural network, and then it knows the data. So that's one approach. Other is to actually code or explain, well, code or type in that the table is a flat surface with 4 legs, but of course these tables fail that. So they have 2 legs.
Yes. I think neural networks
They
are
wouldn't be able to
closest
be recognized for that
explanation,
description.
and I think closest explanation why we can see things like this, and it's neural networks, but at the same time, neural networks, when you use the things that we call neural network now, we lose. We cannot point out part of the memory and call it, okay, this part of the memory is about this object, and we cannot use it as a programmer.
We can.
Well,
We can
very limited.
train the same kind of neural network several times, and then I think you can have several of them. Each one will recognize one kind of thing. It's very expensive. It's better trained on let the same network.
Yeah,
and it's hard to copy out one of those structures.
So my problem is that if you train table and chair, and you want to specify a tripod as not chair or not a table, you cannot add that within. You should spend a lot of time to retrain a whole network. But apparently we can generalize, or we can symbolically define that, okay, this is completely different object now. You can copy this and modify this in our brain. I mean, not well. I cannot say that it happens in our brain. I want to say that as a programmer, I cannot actually do these activities with our neural net classifiers. It's a bit complicated to edit those. The update them needs more samples, more. It's expensive. Yeah, thank you.
Thank you. Yes, you got some answers at least. So, any further? Does anyone there?
I can show a presentation to
Yes, please do.
I need a computer with internet access.
Yes.
My dog is broke.
Can somebody lend this man a computer?
And just need browser.
I think we have a candidate here.
It's amazing how people trust me. No. Who's that?
And it's, it's got a fairly complex window manager.
Yeah. Okay.
No, I don't have any internet.
You don't have internet.
I can give you.
I think it works now.
Did it work?
You need a projector.
Yeah.
You need.
Maybe it takes too long.
It's okay. There's.
I need web browser. It's a Tor browser. Browser doesn't like to be full screen. Well, I think it's less. hang it full screen, but then it breaks. Yeah, don't put it full screen. Put it almost full screen then. Yeah, you don't have to have it, remove the stuff. Just huh?
Let it talk first, and you get my computer later.
Okay.
No, it's, I was joking.
I think it's good to have the talks first and the video in the end.
Yeah. My VGA dongle broke during my speech.
Ah, okay. There you have. I have probably done something to. So.
Is it big enough?
Yep.
So what shall I
github.com/paven/Erik.
And there's a GitHub with the.
/Paven. Is it the P in the beginning? Yeah, and then /Birgit with the large G. Large G. Yep. Then I can probably work from there.
So you didn't have a presentation?
Yeah, I had a presentation on Birgit, but I'm going to have a presentation on the presentation tool. So, my plan is to show you a presentation tool that I used for my talk earlier today. And I really like presentation tools, so I tried a lot, and this is my latest favorite. So I'm going to show you 3 separate pages. One of them is the index HTML. This is the core of the presentation. It's a quite normal HTML page which has style, which defines how the presentation will look. It's nothing special about that. What's special is this part here, where you load in JavaScript and you point that JavaScript to some kind of content containing markdown files. So this script only points to my README file on GitHub, and from there I can create my presentation as long as I follow some rules.
The keyboard is bad, so be careful.
Yeah. So hopefully we'll get the result now. Yeah. So this is how the presentation looks. It's based on my style that I made. Small changes. Putting some purple in to make my employer happy. And it's all based on this README file. Looks like this on GitHub. And if you look at the raw content, which is the content that is loaded by the JavaScript, This is a standard markdown file with a header and then whatever I want on the page. And what separates the slides is this, that's in normal markdown is considered a horizontal row. So I can use the same information for my README on GitHub for people reading there as I used on my presentation for other stuff. So if you like Markdown, I recommend using this tool. It's called Remark.js. Let's see if we can find it here. And there were actually an online version of this where you only have to have your Markdown file and you put it in the web page, and then your content would be loaded so you can present it, but then you don't have control over the styles. So that's why I did my own index HTML. So that's what I wanted to show you. Thank you.
Thank you very much. So, anyone else? Or would you like to watch a movie, perhaps? It seems you are in a movie mood. I see. So, yes. So, I think it will start here in just a moment. I don't know about sound. Do you think we could connect it to this here in perhaps?
I would like to tell you a story connecting the notorious privacy incident involving Adam and Eve and the remarkable shift in the boundaries between public and private, which has occurred in the past 10 years. You know the incident. Adam and Eve, one day in the Garden of Eden, realize they are naked, they freak out, and the rest is history. Nowadays, Adam and Eve would probably act differently. We do reveal so much more information about ourselves online than ever before. And so much information about us is being collected by organizations. Now, there is much to gain and benefit from this massive analysis of personal information or big data. But there are also complex trade-offs that come from giving away our privacy. And my story is about these trade-offs. I will start with an observation, which in my mind has become clearer and clearer in the past few years, that any personal information can become sensitive information. Back in the year 2000, about 100 billion photos were shot worldwide, but only a minuscule proportion of them were actually uploaded online. In 2010, only on Facebook, in a single month, 2.5 billion photos were uploaded, most of them identified. In the same span of time, computers' ability to recognize people in photos improved by 3 orders of magnitude. What happens when you combine these technologies together? Increasing availability of facial data, improving facial recognizing ability by computers, but also cloud computing, which gives anyone in this theater the kind of computational power which a few years ago was only the domain of 3-letter agencies. And ubiquitous computing, which allows my phone, which is not a supercomputer, to connect to the internet and do there hundreds of thousands of face matches in a few seconds. Well, we conjecture that the result of this combination of technologies will be a radical change in our very notions of privacy and anonymity. To test that, we did an experiment on Carnegie Mellon University campus. We asked students who were walking by to participate in a study. And we took a shot with a webcam, and we asked them to fill out a survey on a laptop. while they were filling out the survey, we uploaded their shot to a cloud computing cluster. And we started using a facial recognizer to match that shot to a database of some hundreds of thousands of images which we had downloaded from Facebook profiles. By the time the subject reached the last page on the survey, the page had been dynamically updated with the 10 best matching photos which the recognizer had found. And we asked the subjects to indicate whether he or she found themselves in the photo. Do you see the subject? Well, the computer did, and in fact did so for 1 out of 3 subjects. So essentially, we can start from an anonymous face, offline or online, and we can use facial recognition to give a name to that anonymous face, thanks to social media data. But a few years back, we did something else. We started from social media data. We combined it statistically with data from US government social security, and we ended up predicting social security numbers, which in the United States are extremely sensitive information. Do you see where I'm going with this? So if you combine the 2 studies together, then the question becomes, can you start from a face? And using facial recognition, find a name and publicly available information about that name and that person. And from that publicly available information, infer non-publicly available information, much more sensitive ones, which you link back to the face. And the answer is yes, we can, and we did. Of course, the accuracy keeps getting worse. But in fact, we even decided to develop an iPhone app, which uses the phone internal camera to take a shot of a subject and then upload it to a cloud and then do what I just described to you in real time. Looking for a match, finding public information, trying to infer sensitive information, and then sending it back to the phone so that it is overlaid on the face of the subject. An example of augmented reality, probably a creepy example of augmented reality. In fact, we didn't develop the app to make it available, just as a proof of concept. In fact, take these technologies and push them to their logical extreme. Imagine a future in which strangers around you will look at you through their Google glasses or one day their contact lenses and use 7 or 8 data points about you to infer anything else which may be known about you. What will this future without secrets look like? And should we care? We may like to believe that the future with so much wealth of data will be a future with no more biases. But in fact, having so much information doesn't mean that we will make decisions which are more objective. In another experiment, we presented to our subjects information about a potential job candidate. We included in this information some references to some funny, absolutely legal, but perhaps slightly embarrassing information that the subject had posted online. Now, interestingly, among our subjects, some had posted comparable information, and some had not. Which group do you think was more likely to judge harshly our subject? Paradoxically, it was the group who had posted similar information, an example of moral dissonance. Now, you may be thinking, this does not apply to me because I have nothing to hide. But in fact, privacy is not about having something negative to hide. Imagine that you are the HR director of a certain organization and you receive resumes and you decide to find more information about the candidates. Therefore, you Google their names and in a certain universe you find this information. Or in a parallel universe, you find this information. Do you think that you will be equally likely to call either candidate for an interview? If you think so, then you are not like the US employers who are in fact part of our experiment. Meaning we did exactly that. We created Facebook profiles manipulating traits, and then we started sending out resumes to companies in the US. And we detected, we monitored whether they were searching for our candidates and whether they were reacting to the information they were finding on social media. And they were. Discrimination was happening through social media for equally skilled candidates. Now, marketers like us to believe that all information about us will always be used in a manner which is in our favor. But think again, why should that be always the case? In a movie which came out a few years ago, Minority Report, a famous scene had Tom Cruise walk in a mall, and holographic, personalized advertising would appear around him. Now, that movie is set in 2054, about 40 years from now. And as exciting as the technology looks, it already vastly underestimates the amount of information that the organization can gather about you, and now they can use it to influence you in a way that you will not even detect. So, as an example, this is another experiment actually we are running, not yet completed. Imagine that an organization has access to your list of Facebook friends. And through some kind of algorithm, they can detect the 2 friends that you like the most. And then they create, in real time, a facial composite of these 2 friends. Now, studies prior to ours have shown that people don't recognize any longer, even themselves, in facial composites. But they react to those composites in a positive manner. So next time you are looking for a certain product and there is an ad suggesting you to buy it, it will not be just a standard spokesperson. It will be one of your friends. And you will not even know that this is happening. Now, the problem is that the current policy mechanisms we have to protect ourselves from the abusers of personal information are like bringing a knife to a gunfight. The problem is that it will not be just a standard spokesperson. It will be one of your friends. And you will not even know that this is happening. Now, the problem is that the current policy mechanisms we have to protect ourselves from the abusers of personal information are like bringing a knife to a gunfight. One of these mechanisms is transparency, telling people what you're going.
Yeah, I suppose that was it for this year's lightning talks, and yeah, it actually marks the end of our program. I think the cryptography or the key signing session is still going on if anyone has some unsigned keys still. But yeah, apart from that, you can also sit out here and hang out for a little while longer, have some more beer, or yes. And thank you for coming, and thank volunteers and organizers and speakers and everyone.
Thank you.
Thank you.